Okay, that's not the right thing. Let's try that again. Hi there. This is Jacob Nash, Algebra Lessons, and sorry for that terrible noise. That was a messed up thing. That's not the right thing. So, what song was that? Different intro. What was it? Okay, thank you. That is Same Old Thing. That's on that album by Black Keys, because it is the same old thing that I have to make another unit, because this is probably the only video for this unit, I'm pretty sure, but it's kind of annoying, because I'm sorry that I said there was going to be 7 units, and I said there was going to be 9, then I said there was going to be 8, and then now 9 again. So 7, 9, 8, 9, whatever. That's what we have to do, because there's one last thing that really this maybe could have been on conics. It is the unit circle. That's what the unit is, but that's what the lesson is. So this is just kind of like a short little thing that you should know, maybe, before you do your exam, which I might try to do an exam video, exam review video. Then no more Jacob Nash for the summer. I don't know if I'll do more videos, or not. I don't know. Maybe I'll do pre-calculus ones. We'll have to see. So what is the unit circle? That sounds kind of dumb. The unit circle. That doesn't even seem like correct English. Well, it is a circle that has a radius of 1. So it can be, you know what a radius is, hopefully. It's the distance from the center point to the edge of the circle in any direction. That equals 1. We know from the last unit, maybe we did have a unit circle, but this unit, it only deals with unit circles. So that being said, we know that the points would be 1, 0, negative 1, 0, 0, 1, and 0, negative 1, like in that thing, in that example. So any coordinate of a point on that circle would have the coordinates cosine of theta, which theta is, that means that would be the angle, cosine of theta, sine of theta. That cosine of theta, x value, sine of theta, y value. That is what that is. So all you have to do is know what the angle is, and then you take the cosine and then sine of it, and that's how you know what coordinates there is. So let's see an example. And the angle, by the way, theta would have to be relative to 0, 0, meaning that you start at 0, 0, and you're like, oh, go that way, and you might have to add or subtract a value. We'll see what that means. So find the coordinates of J and H, or sorry, K. Coordinates of J. Alright, let's see. We said that it was the sine of, or cosine of angle, sine of angle. What is the angle that we see? We see here's J, and then we have 51 degrees. Now that kind of seems like geometry. Well, kind of is like geometry, but the only difference is that it kind of seems like algebra also. So 51, we need to do cosine of 51, and I'm going to round to the nearest tenth. 0.6, and then sine of, then we need to do the sine of 51. Then that is rounds to 0.8. So that's what the coordinates are. So does that make sense to what that looks like? Because we can see that if this is a graph, then we would have like a line there and there. And we see, does this look like about, if this is 1, then does this look about like 0.8? Yes. Does this look like 0.6? Yes, so that makes sense. Then let's do K. Now you might see that the angle there is also 51 degrees, but that's not what number we will put in, because relative to the starting point, that is not 51. That is actually going to be we can see starting from here, we use this, the x-axis to the right of the y-axis as the bottom part of our angle, and then we use whatever's there as the top part. So that's why that was 51 degrees. Now we use this at the bottom as the bottom part. So not only do we have this as the angle, we have the whole thing. So we need to know what the whole thing is. So there's 90 degrees on each one of these sections, because there's 360 degrees around, and that's what we'll talk about in a second. But so this is 90 degrees, this is 90 degrees, and we're doing the whole thing, so that's 180 degrees. But we also have the 51 degrees, so 180 plus 51 is 231 degrees. So that's what we plug in. So cosine of 231 is negative 1.6, or sorry, negative 0.6. Sine of 231 is negative 0.8. So it's the opposite values as J. That kind of makes sense because it's in the opposite place. So that's how you do that. Now another thing, sometimes you have to find the angle measure, or theta. So we got 51 degrees up there. What if you have to find it? What do? You have to use SOHCAHTOA. That hopefully is something that you have known before, SOHCAHTOA. But I will still explain it in case you didn't know what that was. Remember, it only works with right triangles, which you might be thinking, oh, I thought this was about circles. Well, we'll see how you can make a triangle out of a circle. But a right triangle, remember, it has a 90-degree angle. That's what that is. And what does the SOHCAHTOA thing mean? It just means that the sine of an angle is opposite over adjacent side of a triangle. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's just all that is. SOHCAHTOA is something to help you remember it, because SOH and then CAHTOA. And what are the hypotenuse, adjacent, and opposite sides? So if we have a right triangle, try to draw it better. Okay. Well, we always know what the hypotenuse is. It's the side that would be the longest, and it's across from the right angle. So this is hypotenuse, or H. Then A and O are called the legs of the triangle, and they can be switched out. Like with the Pythagorean theorem, we call this C, and then A and B can be switched. So it actually is just relative to wherever you're starting, like whatever angle you're trying to find. So let's say the angle we're trying to find is this that I just did in pink. What is that? Well, this would be opposite because it's opposite of that angle. And then this would be the adjacent. But if we had it here, this would be the opposite, and that would be the adjacent. So it's about what you're trying to find. So let's see how that is. Find the coordinates of point M. This looks kind of weird, but we'll see what we do. We need to find the length of all sides, the hypotenuse, adjacent, and opposite. Use this unit circle radius rule, which just means what I said, that it equals 1. And you can use the Pythagorean theorem if you don't know a side. Find the coordinates using the same thing we already did. Cosine of theta, sine of theta. So let's see. Here we made a triangle, and we need to find what, well, first we can label H, A, and O. So we always know that the side across from the right angle is considered the hypotenuse. So let's do that. H. Now, the angle we're trying to find is right here. And so this is opposite, on the opposite side of the triangle. So we call that opposite side. And then this is adjacent to it, which really just means right next to it. So that's why that's A. So we know our sides now. And we could find the values if we wanted to. Well, we could figure out the coordinates well, we would have to find we're going to have to find the angle first, but before we do that, we need to know the length of all sides. We see 1.4 is labeled for the opposite side. Hypotenuse, there's no way to know that. We'll have to use the Pythagorean theorem. But this side down here, we know that that is 1 because, well, we can just see that for one thing, but we also know that because this is a unit circle. So now we can use the Pythagorean theorem, which I think I've already talked about in these videos, but it is a squared plus b squared equals c squared. And c is the hypotenuse, and a and b can be either one. So we can just say this is a and this is b. So a is 1, b is 1.4, c is what we're trying to find, which is our hypotenuse, that. So 1 squared is 1, 1.4 squared, 1.96, and then c squared is just on that side. Then you have 2.96 equals c squared. Take the square root. 2.96 squared of 2.96. We can round to the nearest tenth. It is 1.7 approximately. So now we know that's what that side is. So now we can actually use SOHCAHTOA. And then we can finally find the coordinates of M. So 1.7 is our value. So now that we're done with the Pythagorean theorem, let's just erase that so it doesn't get confusing. Okay, so if we want to know, we need to find out, well, we don't actually, we don't necessarily actually need to find the angle measure specifically because, we know that, above here, the coordinates are sine of theta and cosine of theta. Those are the coordinates. So the cosine of theta, we know that from up here, the cosine of theta equals adjacent over hypotenuse. So adjacent, or sorry, to find the x value, we need to do cosine of adjacent, which is 1, over hypotenuse, which is 1.7. And then for the y value, sine of, we used the SO part, 1.4 over 1.7. And then, oh, I could have done parentheses right here. Okay, that's what we're going to be looking for. So the cosine of 1 divided by 1.7 is, rounding to the nearest tenth, well, actually, that would really just be 1. Well, that makes sense, because that actually looks like it's directly above. The answer I got was 0.9999, and that makes sense, because it looks like it's right above it. Sine of 1.4 divided by 1.7 is approximately 0.1. Okay. Well, yeah. Wait. That can't be correct. Yeah, we must have done something wrong. 0.4 divided by 1.7. Oh. Yeah. 0.8. Huh. Well, I think that's just because this is not to scale. That's the reason why it's like that. But that would be our answer. That's the coordinates of M. That's the reason why. Because that definitely does not look like it is. It would almost looks like the point would be 1.2. But that's just because that's not to scale. So sorry about that. But this isn't necessarily something you would have to do. You usually would just use this rule above here. It's rare that you would have to use SOHCAHTOA, but I just put that there in case you had to. So last thing to look at, rules of radians. So what is a radian? Radian just means the radius. So the whole length around the circle is 2 pi radians. And if radians means radius, so that means 2 pi r. And that makes sense because the circumference is 2 pi r, where r is radius. So also, in the form of degrees, there's 360 degrees around a circle. So that means that 2 pi radians equals 360 degrees. This doesn't mean 2 pi equals 360. We know that would equal 6.28. So what does that mean? Well, just like how you have 1 foot equals 12 inches, those are just 2 units. We know 1 doesn't equal 12, so that's what that means. Radians and degrees are our units, so that's what that means. So if we wanted to figure out what pi radians equals in terms of degrees, we know that if we know this, we could divide by 2 to get that pi radians equals 180 degrees. So there you go. Applying it. So let's see how we can apply this. How many degrees is pi divided by a if radians... Oh, pi divided by a radians if a equals 45 over 41. Now don't get confused by that. I just put that on the side because that's kind of a weird thing to put as a. So we need to figure out how much degrees this is. And we said that pi radians equals 180, so that's all we need to do. So what is 180 divided by 45 over 41? Let's see. 180 divided by 45 over 41. It is 164. So pi divided by a radians equals 164 degrees. Okay. Last question. Find the coordinates of t. Okay, well, we already know that the coordinates of t will be cosine of theta, sine of theta. That is already what we know. So, what is theta? Theta is pi divided by 19/60ths. So that's kind of a weird thing. So if we want that in degrees form, which is a lot simpler, we can just say that we know that we can always replace the pi with 180. So 180 divided by 19 over 60. 19 over 60. Oh, wait. Did I do that? Okay, I got 568. I don't think that's the right thing. Let's try that again. Well, 568 degrees is not a good answer. I think something must have been wrong when I was trying to make this problem. Because 568 degrees would be a hard thing to graph, so that's probably not what I meant to put. So let's just pretend that instead of 19 over 60, we had let's just go with 3. Or actually, let's just do 4. Does that come out evenly? Yeah. Okay, so let's just pretend that's what it was. Even though that doesn't really look like what it would be. 180 divided by 4 is 45. So, really that would mean that these two angle measures are equal because we know the full thing's 90. So now that we know that, all we have to do is replace the thetas with 45 because that's what we know our angle thing is. Our angle measure is. So, now let's do that. Cosine of 45 is approximately 0.7. sine of 45 is, oh. Oh, actually, yeah, that's about the same thing. It is the same thing. Interesting. Oh, well, that's just our trigonometry rules. That makes sense, actually. So they're the same because 45 is a... That's not really something I'm going to talk about because that's not an Algebra 2 topic, but they are the same because it's 45. Alright, so that's our coordinates of t. So with that, that is what the unit circle is. And that'll be it for this video. So thank you for watching, and I'll see you on the next one, which will probably be the last one that's on the exam review. So thanks for watching.